Okay, here we're going to try to find this, make a comparison here. We have two integrals. We're starting with this function. 1/4 e to the x plus e to the negative x. And we want to compare the integral of f versus from a to b versus the arc length of f from a to b and see what that looks like. So the integral is fairly simple. We just set up, go from a to b, and we have this. Okay, now to find the arc length, you're going to need this. We want the square root of 1 plus y prime of x squared. Okay, and we're going from a to b. So what we have to do is figure out what this inside is. So let's work on that. We'll start with y prime, which is f prime. So we have 1/4 e to the x minus e to the negative x. And we're going to have to square that. So we'll go ahead. Okay, that's this whole quantity squared. So we're going to have e to 2x, or 16. And we'll have minus 1/2. And product of these will zero out the exponent, which makes it a 1 then. So that's how we ended up with 2 times 1/4, which is 1/2. And then we have e to the this quantity squared, which would be a negative 2x. And now you're going to add a 1 to that. Okay, so we'll have 1 plus that negative 1/2 is 1/2 plus e to the 2x over 16 plus e to the negative 2x. Now, if we look at that a little closer, we're going to see that we could write it this way: 1 over 16. We'll have e to 2x and plus 8 and plus e to the negative 2x. With a 16 in there. Okay, that's plus 16e to the negative 2x. Okay, and might not recognize it from here, but this can be factored. It's actually a perfect square. So e to the x plus 4 e to the negative x, quantity squared. Now, when we put that under the radical for s, you're going to take the square root of what we just had here, 16 e to the x plus 4 e to the negative x quantity squared from a to b. And that is a positive number inside there. So it becomes this, 1/4 of e to the x plus 4 e to the negative x dx. And we notice if we expand this, we're going to have 1/4 e to the x and then plus an e to the negative x. And we realized, wait a minute, these two are actually the same. Okay, it's the same integral. So it's interesting to just see that for this particular function, the arc length is the same as the integral itself, the definite integral. And since it's positive, so that means the arc length is going to be equal to the area. So that's just an interesting problem.